we've seen that the distance traveled between the R of t and R of t plus delta t positions can be written approximately as delta s equals the magnitude of delta r times delta t. In notating this, this should have been an absolute value. See if we can get the prime in here, and that's starting to look really bad. So let's just say that magnitude of delta r equals the magnitude of r prime times delta t, so that delta s equals magnitude of r equals magnitude of r prime delta t. To find the distance traveled between t equals a and t equals b along the curve, we partition the interval, t interval, from a to b. Don't think that partition was completely visible on the last clip, so apologize for that, but there it is. And we depict the positions corresponding to the r of t sub I and r of t sub I plus 1 points of this curve. So we have this. Now what we want to do is consider just that interval. So we're considering simply just the ith interval in the motion. Now typically the interval will be considered to be a lot smaller than what we've depicted here. We've drawn things a little bit bigger so that we can do some labeling. What we do is we're going to pick a sample point, t sub I star, in our interval, so that t sub I is less than t sub I star less than t sub I plus 1. At that instant, the r vector will be somewhere between here and here, perhaps here. This can be a random selection.